Okay. So in this part, we are going to see how to extend our program to include non-zero Dirichlet boundary conditions. For this, we use this exercise, this example. Okay, so this is our undirected solution, which we use to specify the solution on the boundary. Okay, for this we have mu as 1 and there is no body source term, that is f equal to 0. Okay, so f equal to 0, mu is 1, and okay, so there is a slight name change. Example 3, I have generated two meshes. Two unstructured meshes. Okay, for this example, okay, so this is the first one. Okay, we are going to read that. Okay, now in order to just to verify how it looks like, let's solve a problem with a non-zero f and zero boundary conditions on this new domain. Okay, so this is our domain. Okay, now we are going to change the boundary conditions and we change the f to 0. Okay, so in order to apply non-zero boundary conditions, first we need to know what the DOF values are. Okay, so we create an array solution specified. So here this can be this as well for generic problems with more than one degree of freedom per node. Okay, we have already identified our fixed DOFs. Okay, we already identify the fixed DOF and from the nodes on the boundary. Okay, so what we need to do, so we need to loop over fixed DOF and then for solution specified, okay, so we need to get the DOF. Okay, DOF fixed. Okay, so I'm going to use II just to avoid I's. Okay, so at this DOF, we calculate the solution from this function. Okay, sine x, okay, x coordinate. Okay, so we extract the x coordinate and y coordinate from the mesh object in the position this. Okay, so here our node numbers and divide numbers are the same. Okay, so okay, DOF comma 1. This gives us our x coordinate, and for y coordinate we have okay the second column. Okay, so cross pi x, sorry, sin pi x. Okay, and then cross pi y minus, okay, not cross x pi y minus crot pi crot h pi multiplied by sin h pi y. Okay, yc. Okay, so here we are calculating the value of u at the specified DOF. Okay, our stiffness matrix, force vector, they don't change. Okay, we have this loop, and then after we create the global force matrix and global global force vector and global stiffness matrix, since we have non-zero boundary conditions, we have to account for them in the global force vector. So what do we do here? Again, we loop over the fits DOF array. Okay, here we have DOF. Okay, in F global, so corresponding to that DOF, what we do? We subtract the corresponding column in the stiffness matrix multiplied by the specified value. Okay, so this is an important step whenever we have non-zero Dirichlet boundary conditions. Okay, after this, the remaining steps are the same. So we extract the free DOFs from the global stiffness matrix and global force vector, solve for the system, and then populate those values into the entries corresponding to free DOFs in the solution array. Okay, let's see. Okay, something is wrong. Okay, line 65. Okay, first let's look at solution specified. Okay, it has all zeros. Okay, something is okay. Yeah, so line 37 1. 37 1. Okay, D1 is 0. Right. We have to get the size. Okay, that is our mistake. Okay, okay, still some errors. For 65. Okay. 1, only 1 by 1. Okay, so we should not extract this. Okay, because we have a column vector here. Okay, that's another mistake. Now this should work. Okay, so we have the solution, but on the boundary it is 0. So what are we missing? We are not adding the specified solution to our solution vector. Okay, so we can do it at any place. Okay, so we can not here. So what we do? We do it here. So solution here. So we are adding the specified value to the solution array. Okay, now correct. Right? Okay. So the maximum value should be 1. Okay. So we can again check the maximum value. Okay. So it is 1. Okay. And Yeah, so we can change the mesh. Okay, so we can have a finer mesh. Okay, now it is taking a bit while because of the finer mesh. So it has 10,000 nodes, so 10,000 degrees of freedom. But it should work without any issues. Okay, so this is how we extend our code to solve problems with the non-zero Dirichlet boundary conditions. Okay, so you can experiment. You can have like different setting. You can develop a like an example code on your own to see like if your code works to those different problems, right? So